Hello everyone. How many of you wish to be the best? Yeah, see a lot of hands coming up, right? Yes. So, to be the best, you need to be prepared to be facing the worst. Remember, hard work doesn't guarantee you a success. So is the umbrella. Do you when you go out in the rain, do you feel that the umbrella protects you from the rain? Of course not. What does it do? It gives you the confidence to face the rain. Similarly, by hard work, it doesn't guarantee you success, but what it does, it increases your chances of success. So please, my dear, do not shy away from hard work. Remember, every successful person in this world was sometime a beginner. So we should be prepared to put in our hard efforts. In this lecture, we are going to talk about pressure. We are going to define pressure and also discuss with you what are the factors on which pressure depends. So, let's begin the session. A force can be applied on a surface in any direction. When the force is applied on a surface in a direction normal, that is perpendicular to the surface, it is called the thrust. Thus, thrust is defined as the force acting normally on a surface. A body, when placed on a surface, exerts a thrust on the surface which is equal to its weight. The thrust is the same in whatsoever way the body is placed on the surface. Thus, thrust exerted by a body on a surface is equal to the weight of the body. We must note over here that thrust is actually a vector quantity. If we talk about the unit of thrust, it is measured in the units of force. So the SI unit of thrust is Newton and CGS unit of thrust is dyne, where 1 Newton is equal to 10 to the power 5 dyne. The gravitational unit of thrust in MKS system is kgf and in CGS system is gf. They are related as 1 kgf is equal to 9.8 Newton and 1 gf is equal to 980 dyne. The effect of thrust is expressed in terms of thrust per unit area. This quantity is called pressure. Thus, the thrust on unit area of surface is called pressure. Pressure is produced when a force acts on an object. In most cases, an object exerts force on another object by making contact with it or by touching it. Let us now describe how the effect of force applied by one object on another object depends on area of contact between the two objects. To clarify this, let us take an example. If we push hard on a piece of wood with our thumb, the thumb does not go into the wood. But if we push a drawing pin with a little bit of pressure, we would find that the drawing pin goes into the wood. What do we observe over here? we observe that our thumb does not get into the wood because the force of thumb is falling on a large area of the wood, due to which the force per unit area or pressure on the wood is small. The drawing pin goes into the wood because due to the sharp tip of the drawing pin, the force of thumb is falling on a very small area of the wood, due to which the force per unit area or pressure on the wood becomes very large. It is clear from this example that pressure is the force acting on a unit area of the object, which in this case is the wood. The force of thumb produces small pressure when it acts on a large area of wood, but the same force of thumb produces much greater pressure when it acts on a very small area of wood through the tip of the drawing pin. Thus, the effect of a force depends on the area of the object on which it acts. Let us now define pressure. So, from the discussion that we have done, we can say pressure is the force acting on an unit area of the object. To obtain the value of pressure, we need to divide the force acting on an object by the area of the object on which it acts. So, mathematically, the formula can be represented as pressure is equal to force by area. This formula gives the relationship between pressure, force, and area. The SI unit of measuring force is Newton and SI unit of measuring area is square meter. Therefore, the SI unit of measuring pressure is newtons per square meter, which is also known as Pascal. 1 kilopascal is equal to 1000 Pascal. In the above formula for pressure, we put the value of force in Newton and the value of area in square meter. Then we will get the value of pressure in newtons per meter square or Pascal. We must note that whether we express the pressure in the units of Newton per meter square or Pascal, it means the same thing. This unit, Pascal, is named after scientist Pascal. We can define Pascal as 1 Pascal is the pressure exerted on a surface of area 1 meter square by a force of 1 Newton acting normally on it. That is, 1 Pascal is equal to 1 Newton per meter square. The CGS unit of pressure is dyne per centimeter square, where 1 dyne per centimeter square is equal to 0.1 Newton per meter square, or 1 Newton per meter square is equal to 10 dyne per centimeter square. Other units of pressure are bar and millibar, where 1 bar is equal to 10 to the power 5 Newton per meter square and 1 millibar is equal to 10 to the power minus 3 bar. The atmospheric pressure is generally expressed in terms of height of mercury column. At normal temperature and pressure, the barometric height is 0.76 meter of mercury at sea level, which is taken as 1 atmosphere. Thus, 1 atmospheric pressure is also expressed in a unit atmosphere or ATM. We have just studied that the formula for calculating pressure is equal to force by unit area. Now, since the area is in the denominator of the formula, it means that larger the area of the surface, smaller will be the pressure produced by the given force. And smaller the area of surface, larger will be the pressure produced by the same force. The area of the pointed end of drawing pin is very small, due to which the force of thumb produces a large pressure on the piece of wood. This large pressure pushes the drawing pin into the piece of wood. So, from the discussion, we may conclude that pressure depends on two factors. Now, what are they? The first one is, of course, the force applied, and more importantly, the second one, area on which the force acts. So, the same force can produce different pressures depending on the area over which it acts. For example, when a force acts over a large area of an object, it produces a small pressure. But if the same force acts over a small area of the object, it produces a large pressure. We must note here that the weight of a body is also a force, and it always acts in the downward direction. We have studied that pressure is the force per unit area. Now, this definition of pressure can be used to explain many observations of our daily life. A school bag has a wide strap made of thick cloth so that the weight of the bag may fall over a large area of the shoulder of the child, producing less pressure on the shoulder. And due to less pressure, it is more comfortable to carry the heavy school bag. On the other hand, if the school bag has a strap made of thin string, then the weight of school bag will fall over a small area of the shoulder. This will produce a large pressure on the shoulder of the child, and it will become very painful to carry the heavy school bag. A person employed to carry heavy luggage or other loads is called a porter. We see many porters on the railway station. Porters place a thick, round piece of cloth on their head when they have to carry heavy loads like heavy suitcases, etc., of the passengers. By placing the thick, round piece of cloth, the porters increase the area of contact of the load with their head. Since the load now falls on a larger area of head, the pressure on head is reduced and it becomes easier to carry the heavy load. A sharp knife has a very thin edge to its blade. A sharp knife cuts objects like vegetables, fruits better because due to very thin edge, the force of our hand falls over a very small area of the object, producing a large pressure. And this large pressure cuts the object easily. On the other hand, a blunt knife has a thicker edge. A blunt knife does not cut an object easily because due to its thicker edge, the force of our hand falls over a larger area of the object and produces lesser pressure. This lesser pressure cuts the object with difficulty. A razor blade has very sharp edges, so that it may produce a large pressure to cut things easily. And X has also a sharp edge to cut things like a log of wood easily. The tip of a sewing needle is sharp so that due to its sharp tip, the needle may put the force on a very small area of the cloth, producing a large pressure sufficient to pierce the cloth being stitched. A knife, a razor blade, and an axe are the cutting tools, whereas a sewing needle is a piercing tool. The tools meant for cutting and piercing always have sharp edges so that they may create large pressure on the objects on which they act so as to do the required job easily. When a man stands on a cushion, then only his 2 feet, which is having small area, are in contact with the cushion. Due to this, the weight of man falls on a small area of the cushion, producing a large pressure. This large pressure causes a big depression in the cushion. On the other hand, when the same man is lying on the cushion, then his whole body, having large area, is in contact with the cushion. In this case, the weight of man falls on a much larger area of the cushion, producing much smaller pressure. And this smaller pressure produces a very little depression in the cushion. The tractors have broad tires so that there is less pressure on the ground and the tires do not sink into comparatively soft grounds in the field. A wide steel belt is provided over the wheels of army tanks so that they exert less pressure on the ground and do not sink into it. Wooden sleepers or concrete sleepers are kept below the railway line so that there is less pressure of the train on the ground and the railway line may not sink into the ground. The snowshoes we have large flat soles so that there is less pressure on the soft snow and stop the wearer from sinking into it. So, what have we learnt in this lecture? We have learnt about pressure. So, what should be my central theme? The central theme should be pressure. And what have we learnt? We have learnt about the definition of pressure. We have also learnt about what are the factors on which it depends. So, if we check out with this mind map, we would find that we have defined force acting per unit area of a surface as pressure. We have said that force acts perpendicularly to the surface, and yes, smaller the area, larger the pressure, or larger the area, smaller the pressure. What do I mean by this? I mean that pressure and area is inversely proportional, and we also have found that pressure and force is directly proportional. When the area is increased, the pressure decreases, while the area decreases, the pressure increases. Well, this brings us to the end of the lecture. That if you have any queries, please do write to me at sanyal.shankha@gmail.com. It's given on the screen, and whatever feedbacks you have, in case you have any, please do share with me. It will be a pleasure to be interacting with you with your queries and solving them. Thank you.